Hello, and welcome to Level 3 Inspections Computer Aided Inspection Master Practitioner's presentation. Our objective is to help our clients accelerate conforming parts deliveries through increasing their throughput on all types of precision manufactured parts. All engineers have heard of the triple constraint problem: speed, quality, price. Pick two. If time is money for your business, like it is for most of our clients, you can now have three because we are so much faster and so much better and provide such greater value for decision support than any other inspection method or process. With our computer-aided inspection programs, you can reduce scrap and iterations, saving months and often millions of dollars. By way of background, we are engineers, metallurgical, mechanical engineers with domain expertise in turbine engines, aerospace products, and all manner of precision manufacturing. We're dimensional and tolerance professionals with over 12 years experience using these 21st century optical metrology tools. We understand design intent, manufacturing processes, all of the requirements and specifications, and we have performed nearly 9,000 computer-aided inspection layouts over the past dozen years. If you haven't seen one before, here's what a structured light metrology 3D scanner looks like. On the right, there is a projector that projects a pattern that moves across the surface of the part, while the lens on the left observes the way the lines undulate across that surface, and it digitizes whatever is in the field of view. Millions of data points per individual 3D scan are gathered and merged together into a point cloud that is then converted into an STL file. It is the surface of the part with millions, tens of millions, sometimes even hundreds of millions of data points, completely digitized, usually watertight, and converted to an STL file format for further analysis. Where this fits into the process of making parts is as follows. Everything starts with computer-aided design. The CAD model is the master reference file and is what starts the operation of making a new product. Computer-aided engineering with finite element analysis, strengths of materials, cycling, desktop wind tunnels, whatever it might be to improve upon that design and optimize that design. Then comes computer-aided manufacturing. Regardless of the manufacturing method, some sort of computer control is applied, and they are used to improve production and quality. Our world is computer-aided inspection, shown in the lower right here, and it is back to the reference files from the computer-aided design process, namely the CAD model and the blueprint and all of the other requirements and specifications that are needed. If allowed to, we can accelerate each of these steps, and we have the experience of improving the way our customers dimension their blueprints to get better benefit from our 3D inspection. All of these can help accelerate parts throughput, parts inspection, parts deliveries, and parts conversion to profits. An overview of our computer-aided inspection process is as follows. We scan the part, as we mentioned earlier, and scanners are monochrome, so we designate blue to represent the scan file. The CAD model is represented in gold because it's the gold standard. We don't modify them, we just use them, preferably in native file format to avoid any compression errors. And we align the scan file to the CAD model in a number of different ways, primarily datums, especially for aerospace, but what can also be other features or overall best fit or feature best fit. So there's a number of ways that we can analyze the part compared to the CAD model in this Smart Compare review. While that is going on, we are computer itemizing the blueprint to create an integrated process that goes from the blueprint all the way through to the report form. And then we extract the dimensions, either all of them for a Smart FAI or a subset of them, perhaps the critical to quality dimensions for a Smart Inspect, and deliver all of this comprehensive information in an Adobe Acrobat portfolio over our secure FTP server or our client's secure FTP server. In all, this is digital, it is trackable, trendable, traceable, auditable, and all of our information is also available in XML file format, so it can be integrated into statistical process control systems. Another review of this process is, again, starting with the Smart Print, the computer itemized blueprint that actually creates and merges the data through the inspection process into the inspection report. The Smart Compare is the Smart Scan aligned to the CAD model in the prescribed way, again, typically datums in aerospace. A Smart FAI for 100% of the dimensions reported, or a Smart Inspect for a subset, less than 100% of those. The AS9102 report form with conditional formatting to show nonconformances, automated data processing into a myriad of other reports for engine prime specialty or any other requirement for electronic output and reporting. The results that are non-conforming are actually highlighted back on the Smart Print by changing the balloon color. All of this is done with minimal human input to prevent data massaging error. We have an integrated, automated process for doing this where humans aren't cutting and pasting data. Our customers have told us that this is so easy to understand, and they've gained such great confidence in working with us that they have cut 95% of the dimensional inspection report review time that they used to spend. It used to be a man week for the product engineer and a man week for the dimensional engineer, and now it's a total of a half a day. Around this time, people would like to know a little bit more about accuracy of our process. We're grateful that Arconic required us to get an ISO 17025 accreditation, and in that independent audited process with a proficiency test, we showed that we are accurate to plus or minus 2 microns, plus or minus 78 millionths of an inch. So this is an amazingly accurate process that we've developed. It's also routinely calibrated to NIST certified artifacts and American Association of Advanced Metrology certified artifacts. So there's, again, distinct advantages of computer-aided inspection over any other method. It's comprehensive, the entire part geometry. It's illustrative with the visualization that help people readily understand what's going on with the geometry of the part and the product of the process. All of this leads to confidence and improved decision support, becoming speed in accelerating process optimization, conforming parts deliveries, and conversion of those parts to revenue and profit. We've performed nearly 9,000 of these dimensional quality inspections using these tools, and here's another look at a color plot. This one is static because it's in PowerPoint, but we deliver these as dynamic images in Adobe Acrobat. Rotate, pan, tilt, zoom, and collaborate with colleagues over the internet. The scale can be adjusted to anything. In this case, green is good. It's showing conforming as plus or minus 0.005 of an inch from the nominal CAD model. Non-conforming to the plus material side is shown in warm colors, yellow, orange, and red. Non-conforming to the minus material side is shown in cool colors, light blue, medium blue, and dark blue. The scale can be adjusted to anything, any range, any number of gradations, and it can also be just to the nominal CAD model without any tolerance band. You can learn an awful lot from these, including dumbing them down to simply pass-fail. In addition to the Smart Compare color plot, we also provide other reports, the executive summary of our findings with recommendations on how to correct any nonconformances that we find, the Smart FAI, which shows a view of each feature from the blueprint with a line showing the surface of the CAD model, a line showing the surface of the scan, and any differences where it's measured, the table of numbers that is also replicated in the AS9102 form. Smart Correlate is what we do to validate CMM programs or other inspection programs or even reverse engineering CAD models. The point in this is that we have primarily organized a process to deliver a comprehensive result that is customer ready, The AS9102 form is ready for a quick review from our clients and quick delivery then to their customers. Compared to traditional metrology, there are vast advantages to computer-aided inspection. Compared to CMMs, which fool you, and optical comparators, which lie, there is absolutely no better standard for use on this. And we say this with some confidence because we prove this every day. The optical metrology and computer-aided inspection process is an objective standard of measurement. It's comprehensive as can be with millions or tens of millions of data points. The visualization provides vastly improved comprehension, leading to greater confidence. Everything being digital means that you can always go back and get the information that you want and trend it and track it. And of course, because it is XML file format, it can be put into statistical process control, and it can be done faster and cheaper because no precision alignment fixture is required. It's simply superior to traditional metrology, although we can always correlate to traditional metrology. We've performed hundreds of correlations and we've never failed. We've been performing these computer-aided inspection projects for a very long time and have earned quite a bit of accolades from our customers. The one on the lower here is actually from a correlation study that we did comparing our process to their CMMs, in which we overlaid their CMM touch points to our scan file and showed that everywhere they were touching the part, we were getting the same measurement to 4 or 5 or 6 decimal points. Their conclusion is that computer-aided inspection is a more accurate representation of the feature true size and form, superior to the CMMs. Harold Slatterprice, the Airfoils Division, PCC Airfoils Division Quality Manager, is one of our longest customers and most outspoken supporters. This is his opinion that we are the industry leaders and experts in this computer-aided inspection field. We appreciate that. We've worked with a variety of different manufacturing methods. This one had to do with additive manufacturing of metal parts with the direct metal laser sintering or laser melting. This was for F135 vane segments for Pratt & Whitney, and we got involved with them and rapidly accelerated their dialing in of the added manufacturing process so that they started meeting the production delivery requirements for Pratt & Whitney, and things were going so well for them that they got bought out of the market by arch rival General Electric Aviation, and now this company is called GE Additive. GE is one of our strongest promoters. They love our results, they have confidence in our programs and our process, and our speed helps them get parts that they need faster than any other method. We are strong colleagues and partners with GE Aviation, and they like our work. Mike Iacovone, product quality engineer at GE Aviation, said that I could use his name in this presentation and continues to recommend us to his clients, especially when there's a backlog that needs to be eliminated. And many, many more things are being developed in concert with GE Aviation as we proceed. We are also qualified and approved and preferred by many of the other engine primes, including Pratt & Whitney, Honeywell, and Rolls-Royce. Safran loves our work. We've worked on every single engine primes product through the supply chain and also directly for the engine primes. More people are finding that the best way to leverage our capabilities is to move our inspection process upstream. In investment casting, that means inspect the wax dies and the core dies before you put metal or ceramic in them. In injection molding, inspect the molds. In CNC machining, confirm that manufacturing step 1 makes conforming parts before investing any time and money in manufacturing step 2. And feed the SPC database, building quality in instead of checking for it at the end. Working with 10,000 times more information than any other inspection method, we can make more confident decisions on process improvements and cut iterations and scrap, saving months and oftentimes millions of dollars. There's a number of ways to do business with us. The longest standing method is to ship us parts, and have us provide scanning and inspection services, ship the parts back, get whatever scope of inspection work that is wanted, and we deliver that over our secure FTP server or our client's secure FTP server. We can also optimize the manufacturing process, sort out part fit and function, and even do some reverse engineering of legacy parts if that's what's needed. If you don't want to ship parts out, you will prefer to keep things in-house, we have developed and patented an automated system to perform this computer-aided inspection process on your shop floor with a junior level technician who simply sticks a part in a gripper, barcode scans the router that came with it, and comes back in 12 or 15 minutes, and the part is completely scanned, dimensionally inspected, dispositioned, and the report is put on the server wherever it's supposed to go. This automated system is fast, is effective, and the image shown here is configured for parts up to about 20 inches in dimension. It is also capable of other configurations, and any size part can be automatically inspected. If you don't want to ship parts out and you don't want to CapEx a six-figure inspection system, we can, on a services basis, bring our technology, our technicians, essentially our computer-aided inspection lab, and co-locate it in your plant. We'll bring a configurable scanner, an experienced operator, and perform the engineering and analysis for fast reporting at our headquarters until we can automate that process to be reported automatically and quickly on site. We can arrive in a 36 hours notice, and you get to skip the learning curve, skip the CapEx requirements, and accelerate the benefits of computer-aided inspection, all under a services agreement right in your shop. For those that have purchased 3D scanners, we have developed a telemetrology service where instead of sending us parts, you send us 3D scan files. We analyze them and report them for you, automate the process to give you the answers that you need to rapidly optimize the process and deliver those parts to your customer. This is one of the fastest ways to get benefits from the 3D scanners that you may have acquired. One of the other ways that we've developed to leverage the non-recurring engineering, the setup from a first article inspection, is to spread that across the periodic inspections and the production inspection with a very rapidly decreasing price schedule over quantity of parts to bring the value up with using the tools that we've developed for the first article inspection across the production inspection range. This can get very aggressively priced very, very quickly, reaching as low as $10 a piece with enough volume. This is likely less expensive than any in-house inspection process. We have other things that we've developed from working on this process for over a dozen years, including our Dimension software that starts by creating a balloon drawing, fast and easy, can handle multiple samples, but ends up being an integration tool from any input measurement, including CMMs and E-gauges, and of course optical metrology 3D scanners, to any output report or format, including AS9102, anything that any of the engine primes want, and NetInspect. This is a valuable and useful tool that can handle unlimited number of samples and is available for an individual or site license. And of course, there's a free trial demonstration, or there's a free trial license available on our website at level3inspection.com. We've been working in this field for a long time. We're excited to be handling more projects and expanding our client base to help accelerate conforming parts deliveries across the aerospace supply chain and delivery of airliners to the marketplace. Where do you want to go from here now that you know what we can do, and how soon should we get started to bring these benefits to your operation?